Hi, today we're looking at lesson 3-4 graphing functions. We've had conversation about what a function is based on an equation, a table, and a graph. So y equals 3x plus 2. We recognize this to be in slope-intercept form. What if we had a table? How do we recognize that we have a function? Well, we know that x, or the domain, may not repeat. So as long as we see no x values repeating, we know we have a function. Also, if we're looking at the graph, we understand that a vertical line test, a vertical line traveling over that graph, only hitting one spot at a time, indicates a function. We're going to give the domain all real numbers as well. We're going to give a limited domain. So let's look at our first problem. Scientists can use a function to make conclusions about rising sea level. Sea level is rising at an approximate rate of 2.5 millimeters per year. If this rate continues, this function describes how many millimeters sea level will rise in the next x years. One way to understand the function, such as the one above, is to graph it. We can graph by finding ordered pairs that satisfy the function. Now, we are going to be given a domain. Here you see the D colon followed by a bracketed set of numbers. These are the x values that we're going to be plugging into the function. Our function is x minus 3y equals negative 6. To solve for y, since we're given the values of x, that would make perfect sense. We take our function and we input the x values. First, we're going to simplify the function by subtracting x. We're going to get y by itself. We're going to divide by negative 3. Our new function, which is much easier to work with, is y equals 1/3 x plus 2. We're going to input values of x into the function 1/3 x plus 2. When x is negative 3, our input value is multiplied by 1/3 and added by 2, increased by 2. So for the x value negative 3, we get an output of positive 1. We go through with all the values, inputting x equals 0, inputting x equals 3, and the value 6. So now what we can do if we're asked to graph, we've been given a limited domain, we've put in the value and come up with or calculated the range or y value, and we can take those ordered pairs and simply graph. Example 1b, given a domain again, we see the domain listed in the brackets, our function x squared minus 3. We're going to input the values negative 2, negative 1, 0, 1, and 2. Plugging into the function and calculating, we get our ordered pairs. Now we notice that x squared when we looked at the function, and we can see that this is not linear. It's not like the ones we've been dealing with. This is a quadratic function. Therefore, our result is parabola. You guys check it out. 1a, I want you to, for the given domain, find the ordered pairs and graph them and come back and check your answer. So what we should see, same steps. For the given domain, we're going to simplify the function by adding 2x to both sides. Adding 2x to both sides gives us y equals 2x plus 3. Setting up our table, we're inputting the values negative 5, negative 3, 1, and 4. Substituting those in for x, finding our y values, negative 7, negative 3, 5, and 11. Graphing the ordered pairs, we can see that they fall in a linear fashion. We can see no exponents in our original function, therefore our straight line. Let's graph this function, come back and check your solution. Notice the exponent 2. So the exact same steps, we want to use the given values of the domain. They are given in the brackets above. We create our table, input the values of the domain into the function, squaring x each time, and adding 2. We get the ordered pairs given on the right-hand side of our table, and graphing, again, gives us a quadratic function and a parabola form. If the domain of a function is all real numbers, any real number can be used as an input value. This will be up to you. This process will produce an infinite number of ordered pairs that satisfies the function. Therefore, arrowheads are drawn at both ends of a smooth line or curve to represent the infinite number of ordered pairs. If a domain is not given, assume the domain is all real numbers. So we're going to graph with the domain of all real numbers. We need to choose the values for x. Plot enough points to see a pattern, and then connect the points with a line or smooth curve. Well, let's assess the function first. I see x to the first power and y to the first power. I predict that we're going to have a linear function. So I always want to take values on either side of the y-axis, so negative values of x along with positive values of x. And I'm generating those ordered pairs. We're going to plot those points to see our pattern. Again, we see they fall in a straight line, and I notice we have a negative correlation here. I might make note of this -3 coefficient of x. Graphing this function, the ordered pairs appear to form a line. We noticed that before, and we can connect the dots. Let's graph this function. Does anybody recognize these brackets? We referred to brackets around a variable as absolute value, meaning we're going to take its distance from the origin. So we input a value of -2. The absolute value of -2 is +2. It lies 2 units from the origin. So absolute -2 plus 2 gives us 4. Inputting each one of those, the absolute value of 0, of course, is 0. It is 0 units from the origin. The absolute value of 1, 2, and 3 are 1, 2, and 3. So we can see a pattern here. Around this point, 0, 2, we see 3s and we see 4s. We see some symmetry. What we expect when we graph absolute value is a V shape now, as opposed to the x to the second power. That was a parabola with a curved graph. This is a definite V shape with a vertex. If the graph is correct, any point on it will satisfy the function. Choose an ordered pair on the graph that was not in your table. 4, 6 is on the graph. Check whether it satisfies this function. We're going to input 4 for x. Absolute value of 4 is 4. 4 plus 2 is 6. So we can go back and see that point on our table. +4, +6. We can see that it's going to go through that value. Check it out 2A. You guys do this on your own and come back and check your solution. Let's graph this function. By just saying graph, it says to you we're using all real numbers for the domain. You get to choose the x values that you want. Remember, let's focus it around the origin and the y-axis. Come back when you're ready to check your answer. So, values around the y-axis could be -2, -1, 0, 1, and 2. Yeah, and 3. Let's input those into our function. Calculating, replacing the x value with our domain, that's what x is, gives us our range value or our function at x. These ordered pairs can then be graphed, and we can see once again that they fall in a straight line. Linear function, no powers greater than 1. Let's try check it out 2B. Come back and check your answer. So remember, we talked about absolute value. It says graph the function. Again, we are choosing the domain, all real numbers. let's center it around where we would possibly see that vertex of that absolute value graph. Again, we're going to select our own values, -2, -1, 0, 1, and 2. You can see those calculations, 3, 2, 1, 0, 1. We can see this symmetry here, understanding that we have probably found the vertex of our absolute value graph. Let's watch as we plot those points. We see the values of y going down as the values of x increase. And right here we bounce back up to notice that V shape of that graph. Connect the dots and we can see at -2, our function should give us a value of 3. If we plug that in here, -2 minus 1 is -3. The absolute value is +3. If the graph is correct, any point on the graph will satisfy the function. As we just said, they checked the point 3, 2. Plugging those values in, 2 equals 2, it satisfies the function. Example 3, finding values using graphs. Use a graph of the function, f of x, equals -1/2 x plus 4 to find the value of f of x when x equals -4. It says to use the graph of the function. Well, they've graphed it out for us, and what they've given us is an x value. We need to find the corresponding y value. Remember, f of x simply indicates the function at the value x. So we're going to take this value -4, and we're going to find its corresponding y value. When x is -4, y, the ordered pair that falls on the graph, has to be +6. The ordered pair -4 matches to +6, meaning a -4 here yields a +6 for y. We can say the function evaluated at -4 equals 6. Use a graph of the function to find the value and check your answer. We did that. We took -1/2 of -4, added it to 4, and got +6. Check it out. Number 3. It says use this graph, y equals 1/3 x plus 2, to find the value of x when y equals 3. This is just backwards of what we just did. It says, here's your y value. What is the matching x value? Go ahead and figure that out and come right back. So we're going to work in a backwards fashion this time. It says when y is 3. So now we're on the y-axis. We're going to locate the value 3, and we're going to move over to the function and down to the corresponding x value. So when y is 3, x is 3. Our ordered pair 3, 3 lies on the graph. Check it in the function. We're going to replace y with 3, f of x, which means the same thing. Is that equal to 1/3 of 3 plus 2? Well, 1/3 of 3 is simply 1. 1 plus 2 is 3. It satisfies the function. Please check for your online on PowerSchool the problems that we need to do for our homework, and check with me if you have any questions.